When exploring for an association between two variables at a time, so when performing bivariate analysis, you want to generate a p-value. A p-value less than 0.05 indicates a statistically significant association between two groups. I've generated this table, which should help direct you in determining which statistical test is most appropriate for your data. The first thing you want to ask is whether you're comparing data between two groups that are paired or unpaired. If you're comparing data between two groups of separate individuals, for example, comparing BMI between patients who are Black versus patients who are white, then your data is described as unpaired or independent, and you would select a test from one of the yellow rows. In other studies, the two groups of data that you'll be comparing come from the same individual, but over a period of time. For example, comparing how BMI changes pre-intervention and post-intervention. If that's the case, you want to select a statistical test from one of the green rows. It's important to also consider whether you're comparing data between two groups or more than two groups. For example, are you comparing data between Black and white patients, or do you have a third category of Asian patients that you're also comparing data for? The second thing you want to consider is the type of data documented by your outcomes variable. Is your outcome variable categorical or is it continuous? Additionally, if your outcomes variable is continuous, you need to determine whether that is normally distributed in your cohort of patients, because that'll determine whether you need to run a parametric test of association, such as an unpaired t-test or an ANOVA, versus a non-parametric test. After generating a p-value, you also want to describe this association in terms of the directionality of the relationship and the extent of that association, and that can be done with something like an odds ratio.